Welcome back. In this video, we'll be learning on how to predict the products from reactants in a chemical equation. So let's get right into it. Up on the screen, you'll find that we have carbonic acid plus calcium hydroxide yields blank. And the first step to finding out the products is to realize what type of chemical reaction this is. So therefore, in our example here, this would be a double replacement. So double replacement. And this is because the cations in both molecules here will replace each other. So the hydrogen here will replace the calcium here, and this will then yield new products. So we're gonna do exactly that. We're gonna switch the cations and make our new products. So this is gonna be, so the first one is gonna be calcium carbonate plus HOH. And what you'll realize is that I forgo the small little subscripts here. Now you can forgo the subscripts in these ones because these are polyatomic ions. So we're gonna be keeping the subscripts for these, but any subscripts like the 2 here for the hydroxide and the 2 here for the hydrogen are gonna be forgoed. Now we're gonna be looking at the charges. So for calcium, if we were to uncrisscross the charges here, we'd find that calcium is +2 and hydroxide is -1. For carbonate here, it'd be -2, and for hydrogen, it'd be +1. Now we look at the same thing over here. So we said that calcium is +2, so +2 here. Carbonate is -2, so we're going to put a -2 there. And this HOH, this is literally water. So we're going to rewrite this as H2O instead. Now, since the charges here are the same, we're not even gonna write anything because it can be simplified into just ones here, so we don't even need that anymore. Now we have to balance the equations. Now there are a number of methods you can use to balance the equation, and once you get really good at them, you don't even have to write it out anymore. You can really just do it in your head. But for the sake of the video, we'll write it out to show the thought process. So if you're familiar with this method, we'll be using this one. So we're going to realize that hydrogen on the right side only has 2 atoms, while on the left side it has 4. So what we're going to do is we're going to multiply the water molecule here by 2. So we multiply it by 2. So now we cross this out. 2 times 2 is now 4. And this 2 also carries over here to the oxygen. So this is actually going to become 2 oxygen atoms, and plus the 3 over here, that's for the carbonate, it's going to be 3 plus 2, which is 5. 4, 5. And looking at this, since there's equal amounts of every single atom here, we know that we now balance the equation correctly. Therefore, carbonic acid plus calcium hydroxide yields calcium carbonate and water, specifically 2 molecules of water. Our next example is going to be sodium chloride, aka table salt. Again, the first step we're going to do is we're going to figure out what type of reaction is this. Since we only have 1 molecule on the left side, we know that this is going to be a decomposition reaction. So we're actually going to get sodium and chlorine separated. Now, as you can see, we have done that. It's a decomposition reaction, and we have Na plus Cl. Now, there's one thing you have to remember, is that Cl is a diatomic molecule, which means that it cannot exist with just 1 atom, meaning that there has to be 2 of them. So this is going to be actually Cl2. Now we're going to look at the charges. Na is +1, Cl is -1, and that's why they don't have any numbers here, because we can already infer that's 1. But now we have to balance the equations. There's 2 Cls, so you can use the method like we did last time, but I'm gonna go a bit quick because this is really not that difficult of a problem. But we're gonna put a 2 right here. So now it's Na2Cl2. We have the Cl2, but we don't have Na2, so we're going to put another 2 right here to fully balance it out. Now this is our new equation. It's a decomposition reaction, and therefore 2NaCl yields 2Na plus Cl2. Our next example is going to be hydrogen and chlorine. And this is going to be a synthesis reaction. Remember, that's always our first step. Figure out what type of reaction this is. This is synthesis because we have two elements right here. We're going to combine them to form one compound. So, write that down. This is synthesis. And this, when we combine them, remember, we forego the subscripts. We do not want them unless it's a polyatomic ion. But if it's just a single element, we're just going to combine them into HCl. So that's hydrochloric acid. Now we worry about the charges. So hydrogen is +1, chlorine is -1, so we don't have to write anything here. Now we go ahead and balance the equations. So to balance them, we see that there's 2 hydrogens, there's 2 chlorines because these are diatomic elements. So we're just going to put a simple 2 in front, and we're going to distribute the 2, so that's H2Cl2, and that's our answer right there. Our next example is going to be lithium plus sulfuric acid. And remember, the first step is always to figure out what type of chemical reaction this is. Now, since we have an element and we have a compound here, we know that's going to be single replacement, meaning that the lithium atom here, a cation, is going to replace the hydrogen right there. It's replacing only one thing, so it's a single replacement. So I'm going to write that down. This is a single replacement. Now, we're going to do exactly what I just said. We're going to replace the hydrogen with the lithium. So now we're going to have hydrogen plus LiSO4 sulfate. So, like I said earlier, hydrogen is a diatomic molecule, so they're element, so therefore it has to have a 2 subscript right next to it. Now, we're going to be looking at the charges. So the charges for sulfate is going to be +2 if we uncrisscross. So it's going to be a -2. Hydrogen is always going to be +1, and lithium is also going to be a +1. If you look at the periodic table and its group, it's an alkali metal, so it's going to have a +1. So we're going to put a +1 here. We have a -2 here, and a +1 here as well. So we're going to crisscross. So now we have H2 plus Li2SO4. Now that we've found the charges and done what's needed, we're now going to balance the equation. So you can use the method we used in the first example. So we're going to see here hydrogen first. Hydrogens, they are the same. There's two elements of hydrogen. There's 2 atoms of hydrogen here. Lithium, there's 1 lithium atom, but here there's 2 of them. So we're going to have to put a 2 on the left side to balance it out. And now, sulfate, 1 sulfate, 1 sulfate, that's also balanced. Therefore, the correct equation is going to be 2 lithium plus sulfuric acid yields hydrogen and lithium sulfate, like so. For our final example, we'll have ethylene and oxygen yields blank. Now again, the first thing to do is to figure out what type of reaction this is. Since this is the famous CHO, meaning carbon, hydrogen, and oxygen, this is going to be a combustion reaction. Combustion reactions always happens with hydrocarbons and oxygen. So this is going to be combustion. Great. Now, Combustion reactions always yield carbon dioxide and water. So this is literally the easiest one in my opinion, because you know what the products will be. So it's going to be water and carbon dioxide. The only thing now is to balance the equation. So we don't even need to look at the charges, because all of these are covalent. They're all covalently bonded, not like the other ones, which are like a non-metal and a metal. So let's start off with looking at the hydrogens. So there's 2 hydrogens on the right side. There's 4 on the left. So we're going to have to put a 2 here. So now we have H4 and O2 here. So we're going to have 4 of them. And we're not going to look at the oxygens yet, because typically you want to do the oxygens last. Instead, we're going to look at the carbons. So there's 2 carbons. So that means we need to put 2 carbons on this side as well. 2. Now we can look at the oxygens. So we distribute the 2 to the oxygen, so that's 2. And on this side, it's going to be 4. So 4 plus 2 is 6. Now we have 2 oxygens on the left side. And to get 6 divided by 2 is 3. So we're going to put a 3 on the left side here. Therefore, ethylene plus oxygen yields you water and carbon dioxide. Now, as you can see, we've done all 5 types of chemical reactions, and we try to predict the products using those different chemical reaction types. So remember, if I were to put this in a list, the very first step you want to do is determine the type of chemical reaction. The second one is determine the charges of each atom. And the final step is to balance the equation. These 3 steps are your golden ticket to figuring out the products from the reactants. Alright guys, if that helped you, go ahead, subscribe to the channel, leave a like, and comment any questions you have. I'll see you in the next one. Later!